All right, so we're continuing 3.4. And 3.4 is on linear programming. So linear programming, we learned last time, involves graphing the feasible region, so lots of inequalities overlapping, and then we found the corner points, and then we plugged into another equation, like a profit equation or cost equation, and we maximized or minimized. Okay, so we're going to do the same thing for this. Okay, so it's a little confusing. So it says manufacturing TVs and DVD players, so we'll pretend they're Blu-ray players, requires the use of electronics, assembly, and finishing departments of a factory, according to the following schedule. Okay, I hope that it really doesn't take this many hours to make a DVD player or a television. So we're just going to pretend that we have like a giant pallet or something. We have multiple DVD players or multiple televisions, because this problem is really wrong. All right, so anyway, so it says 3 hours in the electronics department to build a DVD player. And then they send it to the assembly department, and it takes them 2 hours there. And then it takes them, in the finishing department, 2 more hours. So maybe like boxing it up and all that, making it perfect, putting stickers on, things like that. All right, so it's taking a total of 7 hours to make a DVD player. So like I said, let's pretend it's multiple DVD players or like a pallet of them or something like that. All right, so for the TVs, it's taking 4 hours in the electronics department, 3 hours in assembly, 1 hour in finishing, okay? So as we do this problem, we only have a certain number of hours in each department available. So for instance, let's say that you can work 30 hours. So the people in this factory only work 30 hours in a week. Okay, so then the hours available per week in the electronics department is 180 hours. So there's probably like 6 people working. Does that make sense? So you can't work overtime. We can't have over that amount of hours. Okay, so those are the things that are constrained, right? So we have the hours available per week. So we have electronics, assembly, finishing. And the number of hours in electronic has to be less than or equal to 180. Assembly is less than or equal to 120. Finishing is less than or equal to 60. All right. We're going to let X equal the number of DVD players. Or like you could talk about the number of like pallets or bulk. You're making multiple ones, I guess. And let Y equal the number of TVs. All right, so in the electronics department, we have 3 hours for each DVD player, and we have 4 hours for each TV. That's the total number of hours you're going to spend in the electronics department. That needs to be less than or equal to 180. See how it's set up? It's really just following the table that I have for you. So assembly, we have 2 hours for each DVD player. We have 3 hours for each TV. And then finishing, 2 hours for each DVD player, 1 hour for each TV. All right, these are our constraints. We have 2 more. We talked about this yesterday. So what's the other ones? You guys know these? Yeah? Right, it has to be greater than or equal to 0. You can't have a negative number of TVs or DVD players. So we have 5, all in all. All right, so we're going to graph them. So yesterday we talked about the x-intercept, y-intercept method. So I said the easiest thing to do is plug in 0 for x, 0 for y, and just write the 2 points that you get. So when you plug in 0 for x, it's like the x part is covered up. You have 4y is equal to 180. All right, so 4y equals 180. When I divide by 4, I usually divide by 2 and then 2 again. So 90 divided by 2, 45. So it would be 45. So I have 0, 45. The other one, if I plug in 0 for y, so cover up the y part, you have 3x equals 180. So you get 60. All right, so that means I have 0, 45, and 60, comma 0. So I'm going to go up by, let's go by 5s. So 5, 10, 15, 20, 25, 30, 35, 40, 45. I think it's right there. All right, and then 60. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Let me draw it in. All right, this first line we're going to shade below, because if I plug in 0, 0, I have 0 is less than or equal to 180, which is true. So I'm going to shade below this line. So you can do like little arrows. We talked about this before. So just know that we're going to be below that line. You also have x is greater than or equal to 0 and y is greater than or equal to 0, so that means we're automatically in the first quadrant. So right now, with just those 3 lines, we're in this triangle right here. So you don't have to shade it, but just kind of know we're right there. All right, then we have 2 more. Okay, so this next one. So I have 2x plus 3y is less than or equal to 120. So if I plug in 0 for x, I get 40 for y. If I plug in 0 for y, I get 2x equals 120. I get 60 for x. So it's the same x-intercept, but the y-intercept is slightly lower. So it's like we had that triangle before, and now we're just cutting off a little, I call it a sliver. Just a little tiny bit that we're cutting off. Do you guys see that? So it's like that. So we're shading below still. And that will happen occasionally. So basically, if we had anything that was inside that sliver, there weren't enough hours in the assembly department to finish however many you created. All right, and then the finishing department. So 2x plus 1y is less than or equal to 60. So if I plug in 0 for x, I get 60 for y. And if I plug in 0 for y, I get 30 for x. So 30, 0. All right, so that one I'm going to have 0, 60. So we were at 45 on the blue line, so 50, 55, 60. All right, and then 30, 0, so 30. And again, that one is shaded towards 0, 0 because we have 0 is less than or equal to 60. Do you guys see the final shape? It's kind of a strange, like quadrilateral shape. So corner. So it's right there. Yeah.
I think they count by graph.
Oh, I did count by tens, didn't I? You're right. So on the bottom, I did count by tens. So I need to go more, don't I? I was going by 5s. 5, 10, 15, 20, 25, 30. So it should be more out here, right? Thank you. Give Andy his bonus point. All right. So now I need to come up with these corner points. All right, so my corner points are going to be this one, so I'll call it A, this one B, this one is C, and this one is D. And some of them are really easy to find. Okay, so I'm going to write them. So A is easy, it's 0, 0. Another one that's easy is D. We just talked about that. I went by tens on accident instead of 5. So 5, 10, 15, 20, 25, 30, right? So 30, 0. B was the y-intercept for the green line, so it was 40. So 0, 40. Oh, whoops, that's B. All right, and then the C value is the one we need to find. So do you guys remember we did this last time? We had to find C. So this is the last line I drew in the green line I drew in. So it's going to be, so this was the first, second, third. It's going to be the, let's see, the third and second line intersecting, right? So find C. We're using 2 and 3 to find it. Run out of room. I'll write it down here. All right, so if I'm using lines 2 and 3, I'm going to have 2x plus 3y equals 120. And I'd have 2x plus y equals 60. If I just subtract, so I'm going to multiply everything by a negative and add straight down, I get the x's go away. I get 2y equals 60, so y is 30. Okay, so I got y as 30. I need to find x. So you can plug into either equation, it doesn't matter. So if you plug into 2x plus y equals 60, if y is 30, you get 2x equals 30, so x is 15. Right, you just plug in 30 for y, subtract it over, so you get 30. All right, and the last step. So we've done all these steps. So we did the feasible region. We found the corner points. That was step 2. Now we plug in these corner points into the profit equation to find out what gives the maximum profit. So it says up there, so each DVD player has a profit of $40 and each TV has a profit of $32. So your profit equation is going to be 40 for each DVD player, 32 for each TV. That's why I was saying this problem is really outdated. I should have done like Blu-ray players or something. Nobody pays $40 for a DVD player these days. Do you guys even have DVD players?
I don't have it.
Yeah, you don't? You just have a DVD player? Yeah. All right, but you wouldn't be making a profit of $40 off of it, right? Especially if it took you 7 hours to make it. Can you imagine this problem? I got to update. I need to update this. All right, so here we go. So if I plug into the profit equation, I get P equals, so I'm plugging in 0 and 0, so I get 0. The next one, I'm plugging in 40 for Y, so I have 32 times 40. So let's see, so 64 would be multiplied by 2, so 128, so 1280. You guys get 1280? Running out of room. The next one, I'm going to plug in 15 for X and 32, or 30 for Y. So I get 600 plus 960. All right, so 1560. And the last one, I'm going to plug in 30 for X, so you get 1200. So your greatest profit is here. So a profit of $1,560 when you make 15 DVD players and 30 televisions. That's going to be like your last symptom. Okay, good. All right, so you guys try 4. So I want you to graph 4. The other class had trouble with it. Notice you have a negative slope on number 4, on the 4th one. So try that. I'll come around and check. All right, so I saw a lot of right shading as I walked around, so you guys are doing a good job with the shading. All right, so here we go. So we have x values that are less than or equal to 0. All right, so x equals 0 is this vertical line right here. Every single point on that line has an x value of 0. So x values that are going to be less than or equal to 0, that means we want negative values, right? So we're going to shade on the left of the line. All right, the next one is y values are going to be greater than or equal to 0. So y equals 0 is the x-axis. Right, and you're going to shade above that. You want y values to be positive. So every point in this area has a negative x value and a positive y value. So right now we're in the second quadrant. So this is saying second quadrant. A lot of real life problems wouldn't use this, right? I can't even think of anything that would use the second quadrant, but whatever. All right, so we have y is less than or equal to 9. So go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, missed it. And you're going to have everything less than or equal to that. So previously you were in the second quadrant, but now you're going to be shading below this line. So you guys see you're right here right now. All right, and then we have y is less than or equal to negative 2x minus 7. So you're going to go down to the y-intercept of negative 7. Draw your point. Your slope is negative 2. Okay, so if you have a negative slope, in the end it should be going downward. So as you read like a book, you know, you read a book left to right, it's going to go down. So I can go down to right 1, or you could go up to left 1. It doesn't matter, just as long as it's down in the end. All right. And if you plug in 0, 0 for that one, you get 0 is greater than or equal to negative 7, which is true. 0 is bigger than negative 7, so you shade towards 0, 0. So your final shaded region is right here. Mine's very sloppy. All right, so let's draw our coordinates, our corner points. So it doesn't matter what you make A, B, C, and D. I don't know how to get rid of this. I want it to go away. All right, so anyway, there's a C over there. Mine's covered up. Oh, I guess I can do that a little. There we go. All right, and then D is down here. So we have 4 points. All right, so let's go through and find each of those things. So A is easy, 0, 0. B was 0, 9. Did you guys see that one? C, I don't know, but I do know that it's at a height of 9. That helps a little bit. And then D, I don't know what that one is, but I do know it's at a height of 0. It's on the x-axis. Okay, so if I'm finding C, I used the y equals 9, and I used the this other one, this y equals negative 2x minus 7 to find it. So we know the y value is 9, so plug in 9. So I get 9 equals negative 2x minus 7. Add it over, so 16 equals negative 2x. Did you guys get x equals negative 8? So you should get negative 8 comma 9. Yay. All right, and then we're going to find D. It's the same kind of thing. So my D is using y equals 0, and it's using the y equals negative 2x minus 7 lines. So if I set y equals 0, I get 0 equals negative 2x minus 7. Add the 7. I saw this on a lot of your papers. You get negative 3.5. So D is negative 3.5 comma 0. You guys read that, negative 3.5 comma 0. All right, then we come up with the profit equation. So your profit equation was actually given to you. It's negative 2x minus 4y. And we plug in. All right, so we plug in 0, 0. We get 0. We plug in 9. We get negative 36. Okay, this is when Andy was like, oh, it's got to be 0. All right, it's tricky, though, tricky. So the next one, I have negative 8. Gives you 16 minus 36, so negative 20. And negative 3.5 gives you 7, right? Because you're plugging in a negative number. All right, so your answer for maximizing is that. If I said minimizing, the answer would be negative 36. Since I said the maximum, it's 7. Wouldn't you hate for your profit to be negative 36? That wouldn't be good. You'd be losing money. All right, one more. Think we can handle it? Okay, so let's try to graph it again. So it says graph the system of inequalities below. Okay, so this first one, if I do my x-intercept and my y-intercept, if I plug in 0 for x, my y-intercept is 1. If I plug in 0 for y, my x-intercept is negative 2. So I have 0, 1, and I have negative 2, 0. That's the first line. If I plug in 0, 0, I get 0 is less than or equal to 2, which is true, so I'm going to shade towards 0, 0. So I'm below the line. The next one, if I plug in 0 for y, I get 4 for x. If I plug in 0 for what did I say? What am I saying? If I plug in 0 for x, I get 4 for y. If I plug in 0 for y, I get, what am I doing? I said it right, but wrote it wrong, didn't I? 0 for y, I get 4 for x. 0 for x, so if you cover up the x part, I get negative 2y equals 4, so negative 2 for y. So I have 4, 0. And I have 0, negative 2. All right, if you guys count the slope, I think you'll see that these are going to be parallel. This first one goes up 1, right 2, so the slope is 1/2. This one goes up 2, right 4, which is 2 over 4, which is also 1/2. Do you guys see how they have the same slope? So they're never going to intersect. So we get that. If I plug in 0, 0, I get 0 is less than 4. That's true, so I shade towards the 0, 0, which is up towards the origin, right? So now I have an infinitely long strip that's shaded between. So it goes off forever in both directions, and it looks like that. All right, but we have one more line. So we have x plus y is greater than or equal to negative 2. So if I plug in 0 for x, I get negative 2 for y, and if I plug in 0 for y, I get negative 2 for x. So it ends up going through both of these that we already had. And if you plug in 0, 0, you get 0 is greater than or equal to negative 2, which is true, so it shades towards 0, 0. So the strip is kind of cut off on one end. But it does go on forever this way. So it goes forever this way. It's unbounded. Okay, meaning there's not a boundary that goes all the way around. It's unbounded. So when this happens, so when unbounded, plug in corner points and any point inside the region, the feasible region, right? Okay, so when you look at this, there are only 2 corner points. Some people on these problems, they always like plug in the other y-intercept, x-intercepts. Right, there's only 2 corner points. It's right here and right here. Right, the other ones aren't really corners. They're just along those lines. So I'm going to call this one A and this one B. And then I'm going to plug in any point inside the region. So what's a good point? Yeah,
0, 0.
Yeah, 0, 0 is always good. So let's call that C. So I'm going to do A, B, and C, which is inside. Okay, so A was -2, 0. B was 0, -2. And I'm plugging in the function. And don't be worried about f of x comma y. It's just saying your function has x values and y values in it. 2x plus 3y. So if I plug in -2, I get 2 times -2 plus 3 times 0 for y, so I get -4. If I plug in 0 for x and -2 for y, I get 2 times 0 plus 3 times -2. I get -6. All right, and if I plug in 0, 0, I get 2 times 0 plus 3 times 0, so I get 0. All right, and I asked you to find the maximum and minimum values in this case. Okay. Since the one on the inside was the maximum, see how that's the biggest value? There is no maximum. So here's why. I could have picked any point inside that unbounded region. So let's say I picked a point that was way over here, right there. All right, that's going to be like, I don't know, 6, 5. I don't know if it's in the region. But if I plug in 6, 5, do you guys see you're going to have 2 times 6 plus 3 times 5. That's going to be really big. Much bigger than 0. Well, then I could have plugged in like 1 million, comma, you know, like, yeah, since unbounded, you can plug in any number that's in that region. So there's really no maximum. You can get bigger and bigger and bigger. Okay, so write yourself a little note and say, if the maximum or minimum was the point that was inside, then there is no maximum or minimum. So there's no max, but there is a minimum. So this one is the min. So a minimum of -6 at 0, -2. Okay, does this all make sense? Like I said before, this is what put me through grad school. I tutor this all the time. People have a hard time with this. All right, I'm taking it easy on you. I'm making it pretty easy. I'm not giving you like the story problem ones. I'm giving you graph these constraints, plug in the corner points into the profit or cost equation. So it's pretty easy, not bad. You don't have to determine the oats and flowers and all that we did the other day. Oats and flour. All right.